The extraembryonic membranes are temporary structures which contribute to the care and maintenance of the embryo until independent existence becomes possible. The chick embryo has 4 extraembryonic membranes: the thin, most external chorion, the yolk sac, which is connected to the underside of the embryo, the much vascularized allantois, seen here in outline through the transparent chorion, and the amnion, which immediately surrounds the embryo. In the early stages of incubation, there are no definite boundaries to distinguish embryonic from extraembryonic tissue. Eventually, a series of body folds undercut the embryo. The head fold is the first to appear. As the head of the embryo grows forward, the head fold appears to undercut the anterior end of the embryo. The head fold progresses rearward and becomes continuous with the lateral body folds, which undercut the embryo from both sides. During the 3rd day, a tail or caudal fold undercuts the posterior end of the embryo. The tail, head, and lateral folds continue to develop and further separate the embryo from the yolk. By the 4th day, these folds have detached the embryo from the extraembryonic tissues, except on the underside of the trunk, where body wall and intestine remain open. The amnion and the chorion are so closely associated in their origin that they must be considered together. After about 30 hours of incubation, a fold known as the amniotic fold begins in front of the head of the embryo. Eventually, the fold elevates over the head end of the embryo, as shown in this living specimen and in this drawing. This longitudinal section shows that the amniotic fold is formed from ectoderm and mesoderm. Together, the ectoderm and the adjacent mesoderm comprise the somatopleur. Thus, the amniotic fold consists of 2 layers of somatopleur. The amniotic fold grows rearward, and concurrently, the embryonic head grows forward beneath the amniotic fold, so that the head becomes encased in a double hood. The margin of the fold is crescentic, with its side limbs arching over the embryo as lateral folds. At the end of the 2nd day, an amniotic fold elevates over the tail and grows anteriorly. Eventually, the side limbs of the head fold and the side limbs of the tail fold join. This drawing shows the continuity of the head, tail, and lateral folds. Two layers of somatopleure comprise the amniotic fold. Each of the somatopleuric layers consists of ectoderm, and mesoderm. The outer somatopleure is destined to become the chorion. And the inner somatopleure, the amnion. The head, tail, and lateral folds continue to develop. The folds ultimately converge at a common point, the seroamniotic connection. The embryo is now encased in two sheets of somatopleure. The outer somatopleure is the chorion, the inner somatopleure, the amnion. The amnion acquires smooth muscles and contracts spontaneously. These contractions prevent the membrane from adhering to the embryo. The amnion has no neural mechanism, but its muscular tissue responds to mechanical stimulation. The membrane is elastic, and when stretched, snaps back to its original size and shape. The amnion is filled with a liquid which supports and protects the embryo. When the amnion is punctured, the liquid escapes and the sac collapses. The chorion grows rapidly until it eventually envelops the embryo and all the other extraembryonic membranes. The formation of the yolk sac and the formation of the gut are interrelated, so we will first consider some of the steps in the formation of the gut. At 18 hours of incubation, no differentiation of the primitive gut is apparent. At 20 hours, the border of the opening to the foregut, the anterior intestinal portal, becomes visible. The anterior intestinal portal and the foregut progress rearward and are clearly indicated by the insertion of a probe through the anterior intestinal portal into the foregut. The foregut continues to lengthen. The gut can now be distinguished from the yolk sac. This drawing shows more clearly the distinction between gut and yolk sac. The yolk sac consists of endoderm and adjacent mesoderm. The endoderm and adjacent mesoderm together constitute the splanchnoplure. The extraembryonic splanchnoplure of the yolk sac is continuous with the intraembryonic splanchnoplure of the gut. Toward the end of the second day of incubation, the posterior intestinal portal becomes visible. The foregut and the hindgut increase in length toward each other. Eventually, the opening of the gut to the interior of the yolk sac becomes reduced to a short, narrow passage, the wall of which is the yolk stalk. This drawing shows the passageway from the interior of the yolk sac to the gut. The splanchnopluric walls of the yolk sac and the yolk stalk are continuous with the splanchnopluric walls of the gut. The yolk does not pass directly into the gut, but is carried in digested form to the embryo through the vitelline blood vessels. We will now examine the dramatic growth of the blood vessels of the yolk sac. In the early stages of incubation, the yolk sac contains no blood vessels. Eventually, blood vessels appear in the mesoderm of the yolk sac. These vessels elaborate most rapidly from the third to the fifth days. In this extensive system of yolk sac or vitelline blood vessels, the circulating blood carries the digested yolk to the embryo. All of the blood entering or leaving the yolk sac passes through 2 arteries and 2 veins. A ventral view shows these 4 large vitelline blood vessels more clearly. If the yolk sac is cut and laid back, numerous folds are seen on its inner surface. These folds greatly increase the inner surface of the yolk sac. This greater surface area increases the amount of yolk absorption. The yolk sac continues to spread over the yolk, and by the 14th or 15th day, the yolk sac almost completely envelops the yolk. As the yolk is consumed, the yolk sac becomes smaller and eventually is drawn into the body of the chick. The allantois protrude slightly from the caudal region of this 3-day embryo. The walls of the allantois, yolk stalk, and hindgut are continuous and are splanchnopleuric. The cavity between the yolk sac and the chorion and the amnion and the chorion is lined with mesoderm and is part of the extraembryonic coelom. As the allantois enlarges, it pushes into the extraembryonic coelom. The enlargement of the allantois can be observed in living specimens at various stages of incubation. At first, the allantoic sac is quite small. The sac enlarges, and in this later stage is more easily seen. The allantoic sac connects to the hindgut by way of the allantoic stalk. Excretory liquids fill and distend the sac, making it visible from the dorsal side. Here, the embryo and allantois are on the yolk, as they are when developing within the egg. As enlargement of the allantois continues, a rich supply of blood vessels develops in its mesodermal layer. The many blood vessels in the allantois connect with the embryo by way of large allantoic arteries and veins. The allantois enlarges rapidly. After 7 days of incubation, the allantois completely covers the embryo. This drawing of a 7-day embryo shows more clearly the position of the allantois with respect to the yolk sac, the chorion, the amnion, and the extraembryonic coelom. This sectional view shows the splanchnopleuric layers of the allantois and the yolk sac and the somatopleuric layers of the chorion and the amnion. In this 12-day stage, we can identify the yolk sac, which is now considerably reduced in size, the amnion, the chorion, and the allantois. The growth of the allantois, which at this stage almost completely envelops the contents of the egg, forces the albumin toward the distal end of the yolk sac. The mesodermal layer of the allantois fuses with the mesodermal layer of the chorion, forming the chorioallantoic mesoderm, which becomes richly vascularized with allantoic blood vessels. The fused mesodermal layers, together with the ectoderm of the chorion and the endoderm of the allantois, comprise the chorioallantoic membrane. The chorioallantoic membrane is close to the inner surface of the porous shell. This allows efficient gas exchange between the chorioallantoic blood vessels and the outside air. Eventually, the chorion and allantois surround to form the albumin sac. The extraembryonic membranes have functions of respiration, elimination, and storage of waste products, nourishment, and protection, making them essential to the development of the embryo.